Okay, guys, homework review from 2.3, 2.4. This is a very important lesson, so we're going to go through every problem. I'm going to talk about what I need to see, what I don't need to see, but you might have included. Also, on these, the directions in 1 through 7 said write a two-column proof supplying your own correct conclusion and reason. So conclusion and reason, that is an implication of one. So we only need one conclusion and reason. I gave more because I thought you might find that helpful when it comes to preparing for future proofs. So while you did not have to do this, and you shouldn't have done this really the way I did it for you so you can see like what other conclusions can be drawn. Thank you. So first off, number one, given that line AB, so there's AB, is perpendicular to BC. So that's our given information. If two lines or line segments or rays are perpendicular, the conclusion we should draw is angle ABC is a right angle, definition of perpendicular, or you might have just said angle B is a right angle, definition of perpendicular. So that is the next conclusion we should be drawing when we are told that two lines are perpendicular. Beyond that, once you know that angle ABC is a right angle, you could say the measure of angle ABC is 90 degrees, or the measure of angle B is 90 degrees. Definition of right angle. What you should have is in that red box. So if you don't have what's below that, that's probably what happened. You probably don't have that, but it's good to know that that is the next conclusion that can be drawn. Questions on one. Okay. Joe, can you see okay? Okay. Problem two. Given DEF, there is DEF right here. DEF is complementary to HEF. So HEF is here, DEF is there. You see that in our statement of reasons here in our two columns. DEF is complementary to HEF. Well, if they're complementary, that means that the sum of the angle measures is 90 degrees. So the measure of angle DEF plus the measure of angle HEF equals 90 degrees. Definition of complementary. That's what you should have had on your homework last night. By the way, definition of complementary, look diagonal to the left. What do you see diagonal to the left? You see DEF is complementary to HEF. Usually, like let's say 90% of the time, there is a strong tie in that diagonal right to left movement between the reason and the previous statement. So if you're ever stumped on a reason, look diagonally to the left and up and see if that doesn't guide you. All right, once we know DEF plus HEF is equal to 90, you could have said DEF plus HEF equals HED, right? The smaller angle plus that smaller angle equals the combination of those two, HED. That's the angle addition postulate. You then could have said the measure of angle HED equals 90 degrees. That is substitution. And then you could have said angle HED is a right angle. That's the definition of right angle. A right angle has a measurement of 90 degrees. Okay. So again, you did not do 3, 4, and 5 there. You weren't prompted to, but I did it just so you can see what comes next. What you need to have is in the red box. Questions on 2. Marshall.
Like you only have to have it in the red box, and not like write it in.
No, yeah, you should just. Yeah, yeah. If on this, if all you have is, what does it say in the directions? Give your own conclusion or reason. Yeah. So if you don't have the givens, that's all right. If all you have what's in the red box, that's good by me. Questions on 2 before we go on to 3. All right, number 3. Given that angle WXY, here's WXY. Sorry, I'm reading that wrong. WXZ, which is this angle right here, is congruent to angle YXZ. So this angle here where my cursor is congruent to that angle there where my cursor is. So these two angles are congruent. The conclusion we can draw is XZ, find XZ, it's right there. It bisects angle WXY. Definition of bisect is probably what you said, or definition of angle bisect are also acceptable. Either of those is fine, but you should have that in the red box. Questions on that? And there's no other conclusions I could draw from that. That's it. So that's why I didn't do anything after that. I'm going to send you this key once we're done going through it one at a time. So you'll have it over the weekend if you want to study. By the way, we do have a quiz on Monday. It's going to cover everything we've learned this week. That's 2.1, 2.2, 2.7 was tied to 2.2. We studied both those in the same day. 2.3 and 2.4. Can we go on? Oh, Amanda, let me know. No rush. Are you good? Okay. Number 4. Given ray QS and ray QT, so here's QS, here's QT, trisect angle PQR. You see that in our given information here. Our conclusion is PQT, this angle here, is congruent to TQS, this angle here, and it's also congruent to angle SQR, that angle there. That is the definition of trisect, or you might say definition of angle trisector, whatever, but you should have that in the red box. Questions on that? Okay. 5. Given that E, there's E, it's the midpoint of AC, there's A, there's C. We know that AE is going to be congruent to EC. So E is the midpoint of AC, that's given. Our conclusion is AE is congruent to EC, definition midpoint, or you might have said AE is equal to EC. There you go. Questions on that? Yes?
So does it not matter what you have like above that? Like it only matters what you circled in the red box? Does that make sense?
Yeah, so the way the directions read, you had to give the next conclusion, which is right here, and it's and the reason that accompanies it, which is right here. So if you have what's in the red box and that's all you have, you're good. Any other questions there? Okay, moving along. Number 6, given A and R, there's A, there's R, trisect CD, there's C, there's D. We're going to end up with 3 segments that are congruent. That'd be CA, congruent to AR, congruent to RD. That's the definition of trisect. You see that down here in the red box. CA is congruent to AR, is congruent to RD, or you might have said CA is equal to AR is equal to RD. Of course, this is not the only way to name these segments. You could have flip-flopped them, but definition of trisect is the reason on that. Questions there? Okay, number 7. All right, there's a lot going on here. If this were a quiz problem, I probably wouldn't give you a problem like this on the quiz where I say, give me one conclusion, because there's a few conclusions you could draw from this. So we got the diagram shown. That's our given information. Here are some conclusions you could draw. The angle addition postulate, I don't like this one as much because this is true whether or not PQR is a 180-degree angle, right? So while this is a true relationship, I'm not crazy about if that's all you put. I put it here because I'm kind of constructing a proof, but measure of angle PQS, that's this angle here on the left, plus the measure of angle SQR, that's the angle here on the right, is equal to the combination of those two angles, which is PQR. That's the angle addition postulate. We're able to assume from the diagram PQR is 180 degrees. So in the red box, hopefully you had that. Measure of angle PQR is 180 degrees. You might have said assume from the diagram, or you might have said straight angle, or you might have said forms a straight angle, something like that. Any of those 3 reasons would be okay for the reason there. Questions on what's in the red box? All right, then I kept going. I used substitution. So if I know that PQS plus SQR is equal to PQR, and I know that PQR is 180, the measure of PQS plus the measure of SQR is equal to 180 degrees. That is substitution. And then from that, I'm able to conclude that angle PQS and SQR are supplementary. That's the definition of supplementary.
Wait, so would you take off a point if we use number 2?
If you did this right here, or if you did this.
Yeah, the second.
Okay. So if that's a possibility, I would have to take it unless I very clearly stated don't use the angle addition postulate. So if I gave a problem like this on a quiz, I would say, hey, I know the angle addition postulate can be used there, but let's not use it. And here's the reason. Because PQR is 180 degrees, the angle addition postulate is true, whether that's a 180 degree angle or not. Like if it were a 178 degree angle, the angle addition postulate would be true. So while it is a true relationship and a true conclusion that can be drawn from the diagram, like it just doesn't tell the whole story of what's going on, I guess. A good way to say it. All right. Now, I made a little note down here. I said if this is your answer, the reason it should be assumed from the diagram, I don't love it if this is your answer. Eventually, we'll get to where we can jump straight down to this. So that's like a glimpse into the future. Eventually, we'll be able to jump straight down to number 5 here. We'll say P, Q, S, and SQ are supplementary. Assume from the diagram, or you might say form a straight angle, something like that. But for now, let's try not to jump down here yet. Let's include these steps that come before it. So yeah, Grace.
Is PR, is that a line or can you say it's an angle? Like I don't know what.
PR?
Yeah.
PR is a line.
Okay.
Yep.
But the POR is an angle?
PQR is an angle, yes. Yep. It's a straight angle, but it's an angle. Okay. Now, if I gave that on a test, I wouldn't give a problem like that on a test or quiz, I don't think. I shouldn't say I wouldn't. If I do give it, I have to be like clear about what I'm looking for, because there's a few things that can be concluded there. All right. Can we shut the door? Thank you. All right. In problems 8 through 12, draw at least 2 conclusions. So this is different. In the previous set, we were drawing 1 conclusion. Now we're drawing 2 conclusions and give the reasons to support them in a 2-column proof. So here we go. If we know that WZ bisects VY, one conclusion is VZ is congruent to ZY. You see that right there. VZ is congruent to ZY. That's the definition of bisect. That means Z has to be the midpoint of VY. So that's my second conclusion. Z is the midpoint of VY. That's the definition of midpoint. If you said VX is bisected by WZ, that's incorrect. If you said that VW is congruent to XW, that is incorrect. We cannot assume those things. They might be true, but we cannot assume that. Marshall.
Could I have said VZ plus ZY equals VY?
That is a true relationship, and it is true whether VZ is congruent to ZY or not. So while that is a true relationship, there's more going on here than that. I don't love that answer because it doesn't, again, like I said, it doesn't tell the full story of what's going on here. Grace?
For my second, can I say XY or line XY is 180?
Again, like Marshall's response, that's a true, like that is true. That there's a straight angle occurring here. We don't have the third letter to name it, but there is a straight angle like that. There's 180 degrees in every line, but that's true in every line. So I probably would not take that because, like again, it doesn't really tell the story of what's going on here. Cole.
And I said EY and YZW. Wait, VZW and YZW are supplementary.
I would take that. Yeah, sure. Okay. Number 9. PA, here's PA right there, is perpendicular to AR. That's right there. The conclusions we can draw, angle A, or you might call it PAR like I did down here, is a right angle. That's the definition of perpendicular. If 2 segments are perpendicular to each other, a right angle is formed. If that right angle is formed, its measure has to be 90 degrees. So the measure of angle PAR is equal to 90 degrees. That's the definition of a right angle. That's what you had to have, and I want it in that order too. Any questions there? Do we know that that's a rectangle? We do not know that. It might be, might not be. All we know is that angle A is 90 degrees. We know nothing else. Sure. Can we go on? Still waiting. Okay, I'll wait. I'll wait. Number 10. Given that CG, let's find CG. CG is this vertical segment here. They call it a line, but as presented, it's a segment. Oh, you're fine. Yeah, right there. He just got here.
Got it.
Yeah.
Awesome.
Thanks. Okay. So CG, which is right here, bisects BD. There's BD. Well, if BD is bisected, we know that BF has to be congruent to FD. That was my first reason. BF is congruent to FD. That's the definition of bisect. If BD is bisected and BF is congruent to FD, then F has to be the midpoint of BD. That's the definition of midpoint. Questions on that? Okay. 11. Given that AEN is right here, is congruent to GEN, which is right there, it's congruent to GEL, which is right there. Statement number 2, EN and EG trisect AEL, that's the definition of trisect. I do need you to have that. This next one's kind of funky, like we don't really see this show up a lot in geometry. It shows up on occasion, but it's rare. If you're really trying to draw a second conclusion, that conclusion could be EN bisects AEG, that's the definition of bisect, or you might have said EG bisects NEL. If you didn't get that third statement and reason, don't sweat it. Like that hardly ever comes up. So like that's a bit of a stretch. Like just that conclusion, almost always it's going to be this second statement and reason that comes up, just so you know. So as long as you got that one, you're good like 99% of the time. Given that PQS right here is 90 degrees, well, if that's 90 degrees, we know that PQS is a right angle. That's the definition of a right angle. And we know that PQ is perpendicular to RS. That's the definition of perpendicular. Right? Where two segments meet and a right angle is formed, those two segments, or in this case, a segment and a line, must be perpendicular to each other. Questions on 12. Yeah, so again, if you're using the angle addition postulate on like most of these, that's always true regardless of these angle measures. So it's not, again, it's not an incorrect relationship that exists. It's just, it doesn't really tell what's going on. Very Catherine.
What if I said QP bisects RQS?
QP bisects R what?
QS.
RQS. You don't know that. Maybe it does, maybe it doesn't. Like it's possible that PQ is perpendicular to RS, and it's possible that like this is a length of like 20, right? And that's a length of 19. So we have no idea how far it is from Q. It's like I could slide S left and right, and it doesn't change that PQ is perpendicular to RS. Yes?
Can we have said that PQ bisects RQS? Because we know
Angle RQS?
Yeah, angle RQS.
I would take that.
Okay, yeah, that's fine.
Yeah. Yeah, that'd be okay. Kind of jumping over some stuff, which I'm not crazy about that, but I would probably take it, yeah. All right. All right, let's go down to 10 first, and I'll go back to 8. A lot going on here. Just stick with me. We know that OA right here is perpendicular to OC. So what does that mean? It means we have a right angle occurring right here. So you would say angle 1 and angle 2 are complementary. Also, OB, which is right here, is perpendicular to OD, which is right there. So angle 2 and angle 3 are also complementary. So 1 is complementary to 2, 3 is complementary to 2. What are we trying to prove? We're trying to prove 1 is congruent to 3. They have to be congruent because angles that have the same complement are congruent. I'm going to say that again. Listen carefully if you didn't hear the first time. Angles, like 1 and 3, that have the same complement, 2 is their complement, are congruent. Angles with the same complement are congruent. So what do we have to show here? Well, if OA and OC are perpendicular and OB and OD are perpendicular, that means AOC is a right angle. Right? When two segments are perpendicular, a right angle is formed. It means DOB is a right angle. That's the definition of perpendicular. If you lump these together, that's okay. I did it because it's the same reason for these two, right? It's the same thing happening just with two different angles, but it's happening like at the same time, right? So if you separated these, that's okay. But if you grouped them together like I did, that's okay too. What does it mean for these to be right angles? It means that they have a measure of 90 degrees. So the measure of angle AOC is 90 degrees. The measure of angle DOB is 90 degrees. That's the definition of a right angle. We need to make a connection between angle 1, angle 2, angle 2, angle 3, and AOC and DOB. And here's that connection. The measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. Also, the measure of angle 3 plus the measure of angle 2 equals the measure of angle DOB. That is the angle addition postulate. Now we can use substitution, right? If AOC is equal to 90 and DOB is equal to 90, we can take out AOC and DOB and plug in 90. Measure of angle 1 plus measure of angle 2 equals 90 degrees. That's substitution. Measure of angle 3 plus measure of angle 2 equals 90 degrees. So we have shown now that 1 and 2 are complementary and 3 and 2 are complementary. I'm okay if you don't include statement number 6, right? I went ahead and included it, but if you didn't have it, that's okay. 1 and 2 are complementary. 3 and 2 are complementary. That's the definition of complementary. I'm going to say this is good enough. If you got that, that's good enough to show that they are complementary. Our final statement and reason is angle 1 is congruent to angle 3 because angles with the same complement are congruent. So I made a little note off here to the side. It's okay to leave out number 6. Questions on that one? The order might have been a little different. Your given information was probably first. I needed to have 2 where it is. I needed to have 3 where it is. I needed to have 4 where it is. This is probably, I guess you could have put, put 4 up at 2, but then basically it would just take like, it'd be like you grab this right here. I'm going to grab it for a second and take it back. But it'd be like if you grab this and you just like threw it up here, and then everything else gets slid down. All right, questions. Grace and then Mary Catherine.
Why couldn't we switch 2 and 3?
What does it mean for 2 lines to be perpendicular? It means where they intersect, a right angle is formed. What does it mean for a right angle to be formed? It means we have a 90-degree angle. Mary Catherine. Wait 1 second. And in time, we're going to get to where we don't have to show this much detail. Just know that. Like, if this is frustrating right now, just like be patient, hold tight. In time, we're going to be able to like jump over a few of these things. Mary Catherine.
For this one, did you have to show 2 conclusions?
2 conclusions. No, you just had to do a proof. And we were trying to prove that angle 1 is congruent to angle 3. Questions on there? All right. Number 8. We got this diagram here. In this diagram, 5 and 6 are supplementary. 7 and 8 are supplementary. The reason they are supplementary is because of ROS. That's a straight angle, right? And by the angle addition postulate, that straight angle has been broken up into 2 smaller angles. Same thing over here with 7 and 8. ESO, that angle right there is a straight angle. So by the angle addition postulate, 7 plus 8 is equal to ESO. 7 and 8 are supplementary. Also, we're told in the given information that 6 is congruent to 7. There is 6. There is 7. Angles that have congruent supplements, angles meaning 5 and 8 that have congruent supplements, 6 is congruent to 7, are congruent. So 5 must be congruent to 8. I'll say that one more time. Angles 5 and 8 that have congruent supplements, 6 is congruent to 7, are congruent. Therefore, 5 is congruent to 8. And that's what we're trying to prove here. So here's how I did it. I got the diagram as shown. That's given. The measure of angle ROS equals 180 degrees. The measure of angle EOS equals 180 degrees. You could write assume from the diagram. You could say forms a straight angle. You could write straight angle, something like that, just to show that we have straight angles in ROS and ESO. Using the angle addition postulate, the measure of angle 5 plus the measure of angle 6 equals the measure of angle RSO. The measure of angle 7 plus the measure of angle 8 equals the measure of angle ESO. Again, if you didn't lump these together, if you broke them apart, that's okay, but you were using the same reason twice. So it might just be easier on you to kind of like group them together. Looking at 2 and 3, we can now use substitution. The measure of angle 5 plus the measure of angle 6 equals 180 degrees. Same thing for the measure of angle 7 plus the measure of angle 8 equals 180 degrees. That is substitution. 5 and 6 are supplementary. 7 and 8 are supplementary. If you wanted to state that right there, that's okay. I'm not going to require it. We're going to say this is good enough to show that these two are supplementary. We also have our given information. Angle 6 is congruent to angle 7. If you threw this up at the top, that's fine by me. If you had that at statement 1 or statement 2, you could really have it anywhere before the final statement, and it works out just fine. Angle 5 is congruent to angle 8. Angles supplementary to congruent angles are congruent. That was both those proofs were tough, right? I suspect everybody missed it, at least part of it. If you did get it right, you should feel great. Like, those are challenging. So there you go. There's some flexibility on this problem, so if you don't have exactly what I have, that's fine. This is kind of the plan that I mapped out. The given, I'm trying to show the angles are supplementary, and then I'm trying to come to the final statement and reason. Okay. Again, I'm going to send this to you in a bit. I'm not going to take the time to go over 12 because it's like an older problem, but you get the angle is equal to 50 and the complement is equal to 40, therefore the complement is equal to 40. Okay. Let me send a problem to you. I'm going to send the key to you too, but I don't want you to spend any time with the key right this second. Don't look at that. Pay no attention to that man behind the curtain. All right. Let me send this to you. We're going to work on this now. It'll be under assignments. So a warm-up problem for us today. Sorry that homework check took so long, but I think it had to be done, and I hope you got something out of it. I hope you got a lot out of it. This problem that is being sent your way is similar to some problems we have seen before, but there is a significant difference that hopefully you're able to figure out, but I will give you a clue here in about 2.5 minutes or so. This one's a little different to get started, so let me help you out here. Who knows how many angles we're talking about in this problem? Is it 1? Is it 2? Well, let's take a look. We know there's the angle, right? So we'll say the angle is equal to x. See here the word is a supplement. So I'm going to put this in as a placeholder. This does not mean this is what we're going to go with in the end. But whenever you see the word supplement, I want you to think 180 minus x. Okay? As I kind of just scan through it, I see the word complement show up as well. When you see the word complement, again, this is not necessarily what we're going to go with, but when you see complement, I'm going to put in 90 minus x. I'll put that in as a placeholder. Based off the problem, I may manipulate the supplement a bit. I may manipulate the complement a bit. It just depends on what the problem says. So it says the supplement of an angle, that's this angle right here, is 60 degrees less than twice the supplement of the complement. So we're definitely going to be changing this. We're manipulating the supplement. Find the measure of the complement. We're definitely going to be manipulating the supplement. Let's read it one more time. So I teach math for a living. I read these 3, 4, 5 times, right? The supplement of an angle, that's right here, is 60 degrees less. That means we're going to be subtracting 60. Then twice the supplement of the complement. There's a new angle at play here. And that new angle is the supplement of the complement. So if an angle is the supplement, it's 180 minus x. What would the supplement of the complement be? Joe?
180 minus 90.
180 minus, instead of x, the complement, it would be 90 minus x. That's correct, Joe. Again, the supplement means we're going to do 180 minus x of the complement. Well, instead of minus x, we're now subtracting the complement. Are you making that connection? Let's simplify this a little bit. We can distribute that negative, and we get 180 minus 90 leaves us with 90. We subtract negative x, and we end up with plus x. So that 90 plus x is the supplement of the complement. So with that in mind, read the problem a couple more times and see what you get. I'll come back in about 30 seconds. Yes, Grace?
If you're distributing, why is it negative 90 plus x?
Well, it's going to be 180 minus 90, which is
Oh,
positive
okay.
90. Yeah. So the supplement of an angle, that'd be right here. We said we're going to change that, is 60 degrees less than twice the supplement of the complement of the angle. Who can tell me what our supplement is now? Marshall.
Is it 2 times 90 plus x minus 16?
Let's read it one more time and see if it is. The supplement of an angle is, so the supplement is 60 degrees less, minus 60, than twice the supplement of the complement. So that's twice the supplement of the complement. Marshall, that is it. Good job. So now that we have this, we need an equation to solve for x. How many unknowns do we have? How many variables do we have? 1. So how many equations do we need? Just 1. So come up with an equation that allows you to solve for x. If you're stuck, look up front in about 30 seconds and you'll see the equation to use. And I think there may be more than one that works. So if you don't have exactly what I have, you might still get it right. Once you're finished, look up front. That's not the final answer, but it's what x is. So the equation I used is the angle x plus its supplement. Well, an angle plus the supplement is 180. So the angle x plus the supplement 2 multiplied by 90 plus x minus 60 equals 180. We distribute the 2, giving us 180 plus 2x. The 180s are going to cancel out. You add 60 to both sides, and you get 3x equals 60. Divide by 3, and you get x equals 20. Now, what are we asked to find on this problem? Find the measure of the complement. So what would the complement be? 70. 90 minus 20 is 70 degrees. Questions on that? That was a difficult problem. It was, but you've seen it now. Question I get a lot is, might this be on the quiz on Monday? The answer is, you have seen it, so it's possible. It's not guaranteed, but it's possible. Yeah. So that might be something you want to review a couple times over the weekend. Okay. Now, I've got some problems I'm going to send you. 2.4 additional problems. If you want to work with somebody, that's fine by me. But we're going to spend the remainder of class working on these, and then whatever you don't finish, please do finish them for homework. But nothing new to learn today. That's good. Just taking it to a whole nother level. There we go. It's coming your way.